Hello everyone, welcome to AI Anytime channel. In this video, we are going to have a look at AutoLLM. So AutoLLM is a new framework or tool that helps you build RAG based applications faster. Okay, so it's kind of a low code uh, library that helps you build web apps, RAG based web apps, or create LLMs apps within seconds. It has many features, like it supports more than 100 plus LLMs, both open source and closed source LLMs. It has very high level abstract classes to work with. One line, you can use one line to create a query for RAG. It has it has supports of more than 20 vector databases. It also has one line fast API creations. If you want to build some high level APIs or microservices in fast API, it provides you those classes that you can just use and build it. So what it does, guys, in the hood, uh, it's again, I'll not say that it's kind of a competitor to LangChain by any means, to be honest. LangChain is more of an orchestration framework, but this is more of a low code tool, that basically helps you build LLM applications faster. So if you are not that code savvy person who likes to write a hell lot of codes and want to build prototypes faster, you can explore this kind of frameworks or libraries or tools. So AutoLLM is created by SafeVideo.ai, who are the creator behind this beautiful, and that's really looking promising as a library to work with. It also has some cool features like cost calculation that will help you look at the FinOps part of your project, right? It will help you look at the unit economics behind. That's where the future is going. It comes from an LLM ecosystem standpoint. People are looking at to create different orchestration frameworks, how to build these libraries or framework that will help you build applications faster, so where you don't have to write a lot of codes. Okay, now so it has a unified API mechanism that helps you again with simplification of your entire workflow. So let's jump in and let's see how we can experiment with AutoLLM. We'll build a very simple RAG application here. We'll have a GitHub repository and we'll like to talk with the README files or the Markdown wherever possible. So that will be your source data, and then we'll build a simple Gradio app through a Colab notebook and then or a notebook, and then we'll see how it's working. So let's start our experimentation with AutoLLM.
All right, so let's start our experimentation with the Auto LLM, guys. And so for that, you can see I am in my Colab notebook. You can do it in your local Jupyter notebook or a Python app as well, within a Python app or a Python file locally. Now, here, first thing that we have to do, we have to install a couple of things. So the first thing that we're going to do is pip install Auto LLM. Maybe we can also need a Gradio app. Maybe we can build it quickly. Then we need Git Python. Let's have NB convert for notebook and a couple of other dependencies. Okay, and it will installed. It will take a bit of time. And for this, we're gonna use a LangChain documentation, guys. So LangChain GitHub README file we're gonna use and see that how we can use Auto LLM, to treat this as a knowledge base and can query out of it. We can query some information, we can retrieve some information from this MD file. So let's see that. Okay, now, so as we all know that Auto LLM supports local LLMs from Hugging Face as well, that you can also do it out. Okay, so the first thing that we're going to import is, so let's do that. So from Auto LLM import, we're gonna use a auto query engine. So we need some functions and classes, right? So we need, first thing is auto query engine. So let's do that, auto query engine. And then we need from auto LLM, and we need from utilities. So utils, and we're going to use document reading. So it supports multiple type of documents. It supports PDF, HTML file, XMLs, docx, JSON, MDs, Markdown, etc., etc. And from that, I'm going to import read GitHub You can see here, right? It has read GitHub repo as documents. They have built this high level abstract classes for you, right? You don't have to write the code for this, and they have written everything in backend for you. So it's more like, as I already have said, that see this as a low code framework or library that helps you build LLM applications faster. That's what Auto LLM is. You can build web apps, etc., APIs, microservices, powered by large language model. Now this read files as documents, and then also gonna need OS for OpenAI keys, and let's have Gradio thingy here. So import Gradio as GR. Okay. Now we're gonna import this. Okay, and you can see that we have imported successfully. Now the next thing that I'm going to do is I'm going to do os.envarn, because I'm going to set the OpenAI API key in this environment, and this is how you do it. You can also do it from an env file if you want that. Okay, now OpenAI .api key, and here you just do your API key. I already have my API key handy. I'll just copy, and of course I will delete it after this video. Okay, and let me just paste it over here. Now this will set the OpenAI API key. Now let's read the thingy here. Read the documents. So read files as documents. So you can have a different way of querying or building a RAG approach kind of a thing here in this way. We'll see that. Now, so let's call it git repo URL. Git repo URL, and I'm gonna probably use this LangChain thingy. So let's just copy, or not code space. Okay, code local, and I'm going to copy this, and I'm just going to paste over here. This is the repo URL, and then let's have a relative folder path. So where we're going to keep our docs file. Okay, so relative folder path, and here I'm going to call this as documents or docs. So this like containing all the documents, and let's also define an extension, that which extension that we are looking for in this particular GitHub repository, and we're going to call it MD because we are looking at a README file. So let's define that. Now, after defining all of those required thing, we're gonna have a variable called documents, and inside these documents I'm gonna use a class that I have imported, a read GitHub thingy that I have, a GitHub repo as documents, and here I'm gonna pass my git repo URL. So my git repo URL, you can see it over here, it shows already. So git repo URL, and it's the same thing. I'm gonna give git repo URL. Now you're gonna give a relative folder. That's the other thing. You can see it's a path, and relative folder path is nothing but the, and you can also give docs here. You can directly give docs. So let's just give docs. Not required this. Let me just remove it from here. You can directly pass it as well. It's fine. Uh, and what else we have? So we have a required extension. So let's give a required uh, extension. So you can see required extension, and we're gonna just give required extension maybe. Okay, here. Okay, required to extension. Now you can just see here, right, what we are doing. All these abstract classes has been already created for you, and you just have to use this high level functions or high level APIs basically to just use it in your code. You don't have to write everything from scratch. Okay, and that's what the focus is for most of the creators in the open source community. They want to build this kind of frameworks and tools where you can just use it to build LLM applications faster. Now you can see that we have a local folder. When I do a refresh here, you might see it. Okay, you can see Auto LLM has been here, and a lot of things. Okay, Auto LLM temporary. Okay, which is, let's start putting something there. Okay, now let's configure the query engine. So let me just add few cells here, and I'm just gonna make this as text here, and I'm gonna just write auto query. Automatically, you are going to query the document, your docs that you have, the data that you have here. Now inside this, it uses LansDB, by default as the vector store, because LansDB is a lightweight vector stores. But I mean, you can use any other alternatives as well. They provide more others, multiple other, vector stores and vector databases as well. So let's use query engine, and this query engine equals auto query engine and auto query engine, and from parameters or something, yes, from parameters. And here I'm going to pass documents equals documents. So let's do that. Documents equals documents. So let me just write documents equals documents. And now we will run this. Okay, so let's do that. Uh, okay, so documents equals documents. Okay, it says downloading blah blah blah, querying it, and embedding token. You can see generating embeddings, parsing documents into nodes, etc., etc. It has 49, 49 out of here, whatever. Okay, now so start and you can also use some extra advanced uses. You can have your vector store parameters, etc., etc. Here, let me show you how you can do that. So for example, if you have a system prompt, and you can define here in your system prompt that you are an AI assistant that helps users uh, find the most relevant and accurate answers to their questions, something like this. Okay, now if this is your system prompt. Okay, now you can also have a query wrapper prompt, and that is, let's have a doc string here in that case, and inside this you can write the document information is below, and you can pass that as a variable here. That's going to be your context. So let's pass the context string, and to this is your context, and then you can write using the document information and mostly relying on it, answer the query, something like this. Okay, and then you can pass your query. Your query is basically the query question string that you have, that user will ask the question, query string, and then you can just return the answer here. Okay, now this is your query wrapper prompt. Let's just run it. Query wrapper prompt. And you can also it also has a very good feature that comes by default, that's called enable cost calculator. Now that will keep a track of your tokens count. Probably they will be using tick token or whatever, in the backend. So calculator enable cost calculator equals true. Okay, so that's also what, you can do it out here, enable cost calculator true. Now let's use a model here. So I'm gonna use GPT 3.5 Turbo. So GPT 3.5 Turbo model. Let's define that model here. And what else we need here is, let's have a vector store parameter. So excuse me, a vector store, and I'm gonna call it params, or let's call it vector store type. And here I'm going to define a lance db. You can change it over here, guys. Okay, lance db vector store, and you can also define the resource indicator, the table name, blah blah blah, right? You can do that as well. You can customize it a bit. Okay, lance db, let's call it, and then you can have a table name, and in this table name you can just do vectors. Okay, the vectors. Okay, now you can also define the chunk size. Okay, so let's call it chunk size, and chunk size, for example, this is how you can define it. Guys, I'm just showing how you can, you use it, the advanced feature that it provides. Okay, chunk size, and you can also define a similarity top documents. Okay, that how many documents you want to look at it or retrieve. So from 5, similarity top k. That's basically the query engine parameter that you have defined. Now, in the LLM parameters, So call it LLM params, and here it takes a dictionary where you can define your model thingy. So model equals, I mean colon, it is going to be a model, and you can see the LLM. Now the vector store params, you can create similarly vector store params. So vector store, yeah, vector store params, and then will be this will be, this is how you can do it. So vector underscore store and type, and this is nothing but this is going to be your vector store vector store type, and then the next one is your URI resource indicator, and then the next thing is your table name. So table name goes your table name. Oh, table name. Okay. Now this is your vector store parameters. Now you can also do a service context params where you can define your chunking strategy, guys. So service context params where you can define your chunk size. So chunk size is nothing but the chunk size. And then you can have a query engine params. So query engine params, and query engine params is basically the retrieval thing. So you have similarity top k, and this is nothing but the similarity top k. Now what you can do, you can use all of this parameter in your query engine. So let's use that. So in the above that I written here, right, if you go on top, the query engine that we created, this query engine was a very simple one by default, LansDB, and then you use it. But here you have all the options to basically, or let's call it like this, right? Let's call it like query engine 1 or something. Okay, now I'm gonna call it query engine 1. Okay, or let's call it query engine new. Okay, now in this query engine new, what I'm going to do is I'm going to call it auto query engine not from params, I mean from parameters. Okay, it will control J from parameters. And in this you're gonna pass everything, guys. Documents. So documents equals documents you can pass, and then you can also pass your system prompt and a lot of other things. You can pass it over here. Okay, and this is why it is, I mean, very high level, and you say it as a low code kind of a thing where you don't have to write all of this from scratch. So system prompt is equal system prompt. Okay, system prompt equals system prompt. I hope this is what we have defined, right? System prompt equals system prompt. Let me just go up and see. Okay, we have system prompt, and then documents has been given, system prompt has given, then we have query wrapper thingy. Okay, so query wrapper, and query wrapper prompt equals query wrapper prompt. Oh, okay, query wrapper prompt. Okay, query wrapper is done. Now the next thing is we have, let's have it also has a feature that's called enable cost calculator that we have set. So let's call enable cost calculator equals enable cost. You can directly pass through here as well if you want. Okay, it's fine. Enable cost calculator. Then you have LLM params equals LLM params, passing the parameters related to LLM. And then you also have vector store. So vector store equals vector store params equals vector store params that we have defined on top. So vector store params. And what else do we have, guys? We have what else we have defined? We have defined service. So service context. I hope all these arguments are there. Okay, service context params. I have done a pre-study of this before creating this video, and I make sure that I hope this is correct what I am writing. Query engine params equals to query engine params. Come on, okay. Query engine params. It says got another vector store. Something is capital there, guys. Okay, this one. and you can see the tokens has been created. Okay, the embeddings. So here what we are doing, guys, I have created a new query engine. The first one was very default where you're not doing anything, but then you have an advanced UJS where you can customize it completely. That's what we did here, guys. Okay, so far. Now this is interesting because you have like there's something new where you're not using LangChain thingy, right? I mean, the people are creating competitors of a framework like LangChain, etc. Now let's have ask and all. Okay, here you're gonna query it. So let's do ask your question. Okay, now let's do that. Okay, ask your question here. Okay, and let's go up. And here I'm gonna say, okay, let's have a response. So response equals, let's have a query. First, let's have a query engine new thingy. Okay, so query engine new, and inside this you just put your question. You do chain dot run, or you just do chain in LangChain chain, and then you use query equals query like in a dictionary. So it's same thing here. What do we mean by chain in LangChain? Now this is my question in LangChain. It says retriever query engine object is not callable. Okay, so what I am making changes here, guys, mistake here because I'm not using a dot query like we use chain and all, right, in LangChain. It says embedding token uses 10, so it has used 10 token, and you will be in a better position to track your cost because LLM might be costly, right, when you use different services. You can see it costed me around this, and all of those things it has given. So it's better in a way because it gives you a traceability and trackability of your entire workflow. How many tokens has been used, how many completion token has been used, what is the cost that it has occurred or bared for this particular query that you have asked. Now let's print the response thingy and see what we get here, guys. Once you put the response, you get a hash ID first, which is fantastic because this also helps you, from a security standpoint. And you can see let me just go up. Okay, you can find out the response in the context of LangChain. A chain refers to a sequence of components that are executed in order to perform a specific task or achieve a desired outcome. Now these components can include data pre-processing steps, machine learning models, blah blah blah. Fantastic. Now what it also gives you, guys, it gives you a source nodes. Fantastic, because it's looking as the nodes, and it has a different way of, and because we are using LansDB, right, it has a different data structure and indexing technique altogether. Okay, it uses nodes, etc. You can look at the node with its code. It gives you the metadata wherever possible. It gives you the source from which part of the document it has retrieved, etc., etc. And you get some good retriever over here. Well, this is fantastic. I really liked it. At least this part. This is really helpful for a sustainable generative AI workflow. That will help you on from a carbon footprint standpoint, from a money standpoint. You'll be able to keep a track of how much money it's going to cost you and how many tokens that you have used. That's what. Now let's do one thing. Let me make it a little better so you can read it. Let's do response dot. Okay, it's response dot response. It should be. Now here you just get the answer. It says, in the context of LangChain, a chain refers to a sequence of components that are executed in order to perform a specific task, blah blah blah, and you get it here. Now this is fantastic. I mean, this is really amazing. Now let me show you how you can build a Gradio app. And guys, this is the first video on AutoLLM. I'm going to create one other video with open source because this will be a lengthy video if I still create a local in this as well. So let's have that separately. Now this is an introductory video. I wanted to show you how quickly you can do it, and this is working fine, by the way. We have to look at the hallucinations and different concerns that we look at always. Now here so what I'm doing here, guys, I'm creating a, let's not call it greet, let's call chat function. Okay, and then here return query engine dot query, passing the query and just getting the response out of it. And now let's run this first. Okay, and here I'm going to pass my demo, and demo equals gradio.interface. I'm going to use the interface class of Gradio, a library that has a callable function where you can pass your function name that it's going to call, and my function name is nothing but the chat underscore function. So let's pass that chat underscore function over here, and then it has an inputs, and inputs are nothing but the text that's going to input it. It's basically a text box, and then output gonna be again a same thingy here. So outputs equals again a text output that I'm expecting. And now let's do a demo.launch, and you can pass share equals true. It says collab notebook detected to show error, set debug true in launch, blah blah blah. Okay, and you can do that as well. Here I have done. Okay, and you can see that link expire or something it's telling. So you can open this here. It will open in a new like a tab in the browser, and you can ask question guys here. Okay, in the Gradio application, you can give headings and all. I haven't given it yet. Let's ask a question, about LangChain from the GitHub repository, because we have used the markdown here, guys. So we have asked about chains. What can we ask? What is agents? Okay, so let me ask what is agents in the context of LangChain. Let's ask that submit, and what I'm expecting is that it should give me an answer here. Okay, what is agents in the context of LangChain? Okay, now that is what I'm expecting here. And you can see in the context of LangChain, agents refers to the programs or components that have access to the file system, external APIs, or DBs. These agents can perform various tasks such as reading or writing files, interacting with APIs, blah blah blah, and something like that. So you can just see, right, how fantastic it is. We in this so far what we have done, we have build a very simple RAG implementation. I will say it's a retrieval augmented generation that we have done, but completely kind of a black box nature, where you are not having full uh, control on the writing the code. When I'm talking from that perspective, okay, it's completely a low code tool. Understand like that you can use AutoLLM to build LLM applications faster. So far here we have used a lang GitHub repository, the README file, and then we have used created a query engine, and in that query engine we have used LansDB as a vector database, or a vector store rather. And we have couple of customization that we are looking at the type of the vector store, looking at the chunking size, looking at how many documents we have to retrieve, and how many how to create a customized query engine. And then we use that query engine basically to retrieve some responses here. You can look at the source document, metadata, etc., and then we parse the output and build a very simple Gradio application to test it out in the browser. Now, this is as simple as that, right? Now, what if you want to, it also gives you a fast API options as well. You can convert your app in a fast API app. Okay, you can also do that, by the way. You can have your query engine, etc., etc. Let's see that maybe on in this video or maybe in the next video. So let's do that in the next video. I will just stop the experimentation here with AutoLLM in this video. So the code will be available on the GitHub repository, guys. You can go ahead and fork the repository or download the code from there, and you can extend it further.
So that's all, guys. Thank you so much for watching this video. The code will be available on the GitHub repository. You can just go and fork the repository or download and work with it. I hope you learned a few things about AutoLLM. And if you have any thoughts, feedback, comments, please let me know in the comment box. You can also reach out to me through my social media channels. If you haven't subscribed the channel yet, please do subscribe the channel. You can find out multiple LLMs videos in my LLMs playlist. And if you like the content I am creating, or if you like this video, please hit the like icon, okay, and share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.